So we're going to continue validating our arguments here. So we have another one. It says you order the special from B's Eatery, or the French fries are free. The fries are not free. Therefore, you ordered the special from B's. So you can see right here, you order the special from B's Eatery. That's going to be our first simple statement. That'll be P. Here's our or. That's a disjunction. And the French fries are free. That are going to be Q. So this makes up our first premise right here. You order the special from B's Eatery, or the French fries are free. Here's our next premise. The fries are not free. So this is going to be not Q. And then we have our conclusion here. Therefore, you ordered the special from B's. So here is P. So symbolically, our argument is going to look like this. Here's our first premise, P or Q. Our second premise is not Q. And then we separate the premises from the conclusion with a horizontal line. And then we have therefore P. And of course, we're going to see if this is a valid argument. So we go ahead and we put in our standard values here. We can see that we have a negated Q here, a not Q. So we'll put that in. And then I'm going to go ahead and put in my first premise here. P or Q. And we know that that's a disjunction. And it has the pattern true, 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 and false. Both simple statements have to be false. Now the idea is this assertion, this premise here, and this assertion or this premise here, we have to be able to determine if this one and, notice how I say and, this one, see if these assertions support the conclusion here. So I'm going to do an and here. P or Q and not Q. And of course, since this is a conjunction, they both have to be true. So it's true right here, and it's true right here. The rest will be false. So the idea is, in order to arrive at a conclusion, if this is okay, then it should support this. And of course, if then, that winds up being a conditional statement. So we have to write it as a conditional statement. So if P or Q and not Q, then P. And I like to read it as conclusion. This concludes, or therefore. And again, since this is a conditional, our antecedent here, when that's true and our consequent is false, the entire thing is false. So there are no true falses. So this is all true. And since everything's true, it's a tautology, it's true, then this is a valid argument. Let's try one more argument. Here we have Olivia likes tomatoes, but she doesn't like cucumbers. If she doesn't like cucumbers, then she doesn't like veggie salads. Therefore, Olivia likes tomatoes and veggie salads. So we could see right here, Olivia likes tomatoes. So that's probably P. That's probably our first simple statement. I'm just going to write it in right there. Here's but. But is a conjunction just like and. Olivia likes tomatoes, but she doesn't like cucumbers. So this is just a conjunction very much like and. She doesn't like cucumbers. So this is our second simple statement, and it's a negated one. So I'm going to say not Q. So you can see Olivia likes tomatoes, but she doesn't like cucumbers. That has the same effect as saying Olivia likes tomatoes and she doesn't like cucumbers, but we use but. So this is our first premise. Our second premise, if she doesn't like cucumbers, so you can see that that's a not Q. If not Q, then she doesn't like veggie salad. So we've got a third simple statement here, and it's going to be a not R. So if she doesn't like cucumbers, then she doesn't like veggie salads. Therefore, Olivia likes tomatoes and veggie salads. So there we have it. Now we're going to write it symbolically. So we have our first premise, P and not Q. We have our second premise here, if not Q, then not R. Of course, we separate the premises with this horizontal line, and we put in our conclusion, therefore, P and R. And again, we go ahead and we build the truth tables to see if this is a valid argument or not. So here we have three simple statements, P, Q, and R. So our standard values are going to have 8 rows. The first half here is going to be true. And then for the second simple statement, we cut that pattern in half. And then for the last simple statement here, we just wind up alternating. Now you can see that we have a not Q, so I'm going to put in a not Q. That negates it. And I also have a not R, so I'll put that in. So now I'm just going to go ahead and enter each one of these compound statements in there. So I'll do P and not Q. Here we have if not Q, then not R. And then we have P and R. I'm squeezing it in because I'm going to need some room here. Here is a conjunction. Both have to be true for the entire thing to be true. So we have true here and true here. We have true here and true here. The rest will be false. It seems to be tedious work, but there's no other way. Here we have a conditional statement. The antecedent has to be true. The consequent has to be false for the entire thing to be false. So it's true, false right here. And it's true, and false right here. Other than that, it's going to be true. And for this last compound statement, P and R, they both have to be true for the whole thing to be true. It's true here and true here. It's true here and it's true here. Other than that, everything's false. Now, both assertions here, both premises, have to work together. This one and this one, again, notice how I say and, have to support the conclusion. So we'll build the truth table for the first premise and the second premise. So P and not Q, and if not Q, then not R. Again, a conjunction. This must be true, and this must be true for this entire thing to be true. It's true here, and it's true here. So this is true, and that's the only spot. The rest is false. So then our premises here have to confirm our conclusion. So if this is okay, then this should be okay. And of course, that's an if-then. That's a conditional statement. So we'll write it as a conditional statement. If P and not Q, and if not Q, then not R. And I like to read this as therefore P and R. Our antecedent has to be true, and our consequent has to be false for the entire thing to be false. So our antecedent is true right here, and we go in the direction of the arrow. Our antecedent is true right here, and our consequent is false right here. So right here it's false. Other than that, it's true. So what does that mean? Well, this is an invalid argument. This is not a tautology. Every argument is not true. Every truth value is not true. So this becomes an invalid argument. And you only need only one truth value to be false. And then the whole argument then collapses. So there you go.